Let's take a quick look at geothermal, which is renewable in the sense it is getting exhausted. Earth, when it formed, had this core and mantle where even in the crust there are isotopes which have radiogenic activities and produce heat, and they can be captured at low carbon emissions depending on how you do it, plus the total heat energy that's available is estimated to be almost 100 billion times the energy that's the world is using in a year. So that's fairly massive. Using our ranking methods and costs and benefits, the reduced CO2 is estimated at 16.6 gigatons, net cost at minus 155.5 billion, so its return is going to more than outweigh the investments, even though if you read the book section, it'll tell you that there are places where implementing a geothermal energy system is not so cheap. But remember, we are talking about global, and the net savings is estimated at 1.02 trillion US dollars, and this is ranked at number 18 on the list. And this is the map showing the plates, and you can remember from your basic courses, maybe even in high school, that the Pacific is known as the Ring of Fire because of all these active plates meeting each other. So you have the Nazca Plate moving southeast, you have the Pacific Plate, the Aleutian Trench, and all these red dots here are active volcanoes, and you probably heard of the saunas or hot springs that are available in places like parts of Russia, Japan, Iceland, and so on. So you can see that there are some places where there is remarkably no red dots. Of course, this is an active earthquake area as India keeps pushing into the Asian plate there. The examples of common geothermal heat pump installations include simple things like this, and then there are many more complicated multiple cascading systems. So here just a circulation is set up to some depth where the temperature remains at a fairly constant level because of the way diffusion of heat works from the Earth's interior towards the surface. And you have more complicated systems like this, where you have two well system where you are taking energy from one and then circulating with the other. And there is the pond system. Again, you can read it up, but I'm just showing this for the sake of completeness and didn't want to leave it completely without any figures. And this is the horizontal geothermal circulation system. All of them rely on essentially the same principle, that the Earth's interior gets very warm very quickly as you go deeper, and if you put some sort of a circulation system, then that heat can be used either for direct use or for indirectly generating geothermal energy. This figure shows in terms of megawatt equivalents how the geothermal energy exploitation has happened since the mid-1970s. There has been a steady increase from less than 2,000 megawatt equivalent to more than 10,000. So obviously megawatt equivalent means it's not directly power that's being generated, but it's indirect heating and cooling systems or other forms of energy use. This is the later part where installed capacity trends, navigating through the filters to explore trends in renewables. So this is from IRENA again. This is from the it's from the World Energy Resources report on geothermal energy. So you can see that the trend continues in terms of installed geothermal capacity, now at over 14,000 megawatts. Worldwide growth in installed geothermal direct use capacity has also increased and is much larger than the installed capacity here in terms of indirect use. So that's much larger than here 50,000 megawatt equivalent. Just some numbers to keep in mind. The uses include geothermal heat pumps, space heating, greenhouse heating, aquaculture pond heating, think about that, agricultural drying, industrial uses, bathing and swimming, very common in many places, including some places in Europe, cooling and snow melting and others. So these are different years from 1995 to 2010, and most of them show a serious increase, especially in terms of the geothermal heat pumps has gone from just about 5 to 10,000 terajoules per year to now more than 200,000 terajoules per year. Same for bathing and swimming. So these are very good tourist attractions, of course, and people talk about medicinal properties of the high sulfur content in these natural saunas. Okay, comparing CO2 emissions from electricity generation in the USA in gigatons CO2 per kilowatt hour. Geothermal is down here. Pretty much everything else, natural gas, oil, and coal, of course, are an order of magnitude larger. So that's important to remember. Now there are techniques being used called enhanced geothermal systems and so on, where heat sources are located, and typically the heat you get in these circulation systems is because naturally available water is getting heated, and then you can tap into it either for saunas or for heat pumps. But now ideas are being developed to pump heat, like in fracking, where pore spaces are pumped with water to push out the oil that's stuck as shale or in pore spaces of the rocks and so on. Cost-benefit ratios, etc., can be not as simple as what we mentioned here. Plus, there is also release of CO2, sulfur, and other gases that are not necessarily greenhouse friendly. Plus, there is potential contamination of groundwater. There is also potential for earthquakes, like it happens in fracking and so on. So one has to be aware of all those things. As far as I could find, there are no active geothermal plants in India, but this paper here identifies various regions with various temperatures of heat, temperatures at which heat is available and could be exploited for geothermal energy, direct and indirect power generation. Okay, direct heating or indirect power generation. This is a short section concluding the impacts from drawdown. Our calculations assume geothermal grows from 0.66% of global electricity generation to 4.9% by 2050. That growth could reduce emissions by 16.6 gigatons of carbon dioxide and save $1 trillion in energy cost over 30 years and $2.1 trillion over lifetime of the infrastructure if it's continued beyond the time scale we are looking at, 2050. By providing baseload electricity, geothermal also supports expansion of variable renewals. So in terms of meeting dispatchability requirements for the intermittent sources like solar and wind, geothermal can provide the base load where you can always build excess on top with the renewables. So that's the geothermal story, which is could be a big part of the solution. Each of these numbers we are talking about, gigaton CO2, you have to compare with the emissions gap that I talked about in the first podcast. Okay, so totally how much we want to draw down and how each of these sources can add up to meeting that goal. Okay.